Hello there, Mr. Sutton here, bringing you the IM3 8-3 Extra Practice #1 solutions on theoretical probability. For this one, we want the probability of drawing a 4 out of a standard deck of 52 cards. So our total possibilities are going to be 52 on this one. And how many 4s are in a deck of cards? Well, there's 4 of them, one for each of the 4 suits. So that's 4 out of 52, which we can reduce to 1 over 13. For this, we want the probability of drawing a diamond out of a deck of cards. So there's 52 cards total, so that's our total possibilities for this one. And the probability of a diamond, well, how many diamonds are in a deck of cards? There's 13 of each suit, including diamonds, so that's 13 over 52, which reduces to 1 over 4. On this one, we're trying to find the probability of drawing a face card, that is a heart, out of a deck of 52 cards. So our total possibilities are 52, total possible outcomes. And then how many face cards are hearts in a deck of 52 cards? Well, there's 3 hearts that are face cards, the Jack, the Queen, and the King of Hearts. So that's 3 out of 52. And let's see here, can't reduce that, so that's going to be as good as it gets. On this one, we want the probability of drawing a face card that is black out of a deck of 52 cards. So our total possible outcomes are 52. That's our denominator for this probability. And for the desired outcomes, well, we need black face cards. So we have the Jack, the Queen, and the King, but we don't want all of them. We just want them for the clubs and the spades, the 2 black suits. So that's 6 total cards. And then 6 over 52 can be reduced by 2s. That gives us 3 over 26. For this one, we want the probability of rolling factors of 6 on a single die. So we have 6 total possible outcomes. And how many factors of 6 are there from 1 to 6? Well, let's see. 1 is a factor of 6, as is 2 and 3. 4 is not, 5 is not, but 6 is a factor of itself. So that's 4 desired outcomes that we could get here, and this is going to reduce to 2/3. For this one, we want the probability of rolling an odd number on a single die. So we have 6 total possible outcomes. That's our denominator for this. And out of the numbers 1 through 6, there are 3 of them that are odd, 1, 3, and 5. So that's 3 out of 6 then. So that gives us 1/2 if we reduce it. For this one, we want the probability of rolling factors of 2 on a single die with 6 sides. So let's see here. We've got 6 possibilities, and then the ones that we want, the factors of 2, well, 2 is a prime number, so its only factors are going to be 1 and itself. So that's 2 possibilities that we actually want, desired outcomes. And then 2 out of 6 reduces to 1 out of 3. For this one, we want the probability of rolling less than a 4 on a single die. So our total outcomes are 6, 1 for each of the sides of the die. And then less than 4, well, there's 3 numbers on a die that are less than 4, 1, 2, and 3. So that's 3 out of 6, which reduces to 1/2. For this spinner, we want to know the probability of spinning the spinner landing on a 1. So let's see, how many total outcomes do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total outcomes. So it's going to be something over 11. And nothing reduces with 11, so whatever we see is what we get here. So the probability of getting a 1, now how many 1s are there? How many desired outcomes? We've got 1, 2, 3, 4, 5 of them, so that's 5 out of 11. For this one, we want to know the probability of this spinner here landing on a 2. So if you count them, you'll see that there are 11 total spaces. So something over 11 is our probability. And now let's count up the spaces that are actually 2s, the desired outcomes. We've got 1 here, another one here, and coming all the way around, a 3rd one over here, and that's it. So 3 out of 11. On this problem, we have a spinner with some letters, and we want to know the probability of spinning a B or an E. So let's start with the total possibilities. There are 8 different spaces here, so that's going to be our initial denominator for our fraction. And then we want the spaces that are B's or E's. So let's go through and count them. We have an E, there's 1, a B gives us 2, we have a 3, 4, and 5 up here. So that's 5 things that are either B's or E's, so 5 out of 8. For this problem, we want to know the probability on this spinner of not landing on B. Okay, well, let's just figure out first off what our total outcomes are. There's 8 spaces, so it's going to be something over 8. And how many of these are not B? Well, just mentally, probably the easiest way to do this, since there's so few B's on here, is to figure out how many of them are B's and then just subtract that from 8. So we only have a single B on here. So that means the ones that are not B has got to be 8 minus 1, which is 7 out of 8.